Good morning, everybody. Thank you very much for attending today. I'm really pleased to introduce you to Marija Stanojevic. She is a lead applied machine learning scientist at EudAImonia, Science and Ellipsis Health. She focuses on representation learning, multimodal, multilingual, and transfer learning for cognitive and mental health for healthcare. She was a virtual chair for ICLR 2021 and ICML 2021, general chair of the Machine Learning for Cognitive and Mental Health workshop at AAAI 2024, and main organizer of the 9th Mid-Atlantic Student Colloquium of Speech, Language and Learning, MASC SLL 2022, general chair. She also worked at Meta, Cambridge Cognition, Winter Light Labs, and LinkedIn. Let's welcome Marija.
Thank you. Okay, good. Hello, my name is Marija. I will be speaking about machine learning today. I have a PhD in machine learning, and as you have heard, I mainly worked in healthcare, and in the last few years, I focused specifically on mental health. So this talk is not related to any of that, but I learned about this 6 months ago, and it sounded like a topic that would become really important in the years to come for both research and production, and especially in healthcare and mental health, where the data is very sensitive. So I think it's a very interesting time for all of you to learn about this, because I think you will keep seeing it more and more. Before everything starts, I would like to ask, how many of you have ever heard about machine learning before you saw the agenda? 1, 2, 3, 4, 5 people, 6 people. Okay, great. So we all have heard for machine learning, but what is machine learning? So the goal of it is to remove the effect of specific training data from a trained model. And so why would you want to do this? Well, I'm going to go into that in the next few slides. And you can imagine that as the models are getting bigger, as we are getting more and more data from different resources, it would be harder to remove them, specific type of data from your training, without retraining the whole model, which in case of LLMs can be costing you millions of dollars. So where does it make sense to do machine learning then? To remove your data in some other way than retraining your model without that part of data. So it makes sense in any neural networks, but specifically in larger neural networks where it costs a lot to retrain. It makes sense in bagging and boosting algorithms, and also in graph representation learning. As you can see, what's the same for all of this is the data is very complex. The algorithms we build on top of this data are very complex. There is a lot of connections between the samples or between the features, and it will be really hard to disentangle them if you need to remove just some part of the data. And so it makes sense to learn to think of algorithms, how we can remove these parts of data that we don't care about without full retraining. And I'm going to focus in this talk on neural networks, specifically on deep learning, and we will talk also mostly about LLMs and multimodal models and big computer vision models, because these are the use cases where this makes the most sense and where this is most needed. And also these are the use cases where people are testing this now on, where most of the research is done on. Okay. So what exactly does it mean, and what is the goal of this? For machine learning, we have some data, and the goal is through training to come to a trained model that would predict some classes or generate something or whatever. For machine learning, we are actually kind of doing an opposite thing, and we are starting from a trained model where the goal is to also produce a model that would work well for everything else except for the data we would like to forget or unlearn. And unlearning process can be anything. Like there are lots of things, and it's also lots of ways for you to unlearn. the data, and we are going to go through those techniques. But also what you are unlearning can be a lot of different things. You can unlearn items, you can learn whole data set or classes or whatnot. In this example here, we are trying to unlearn dogs because we are cat people. And so the goal is to try to forget that dogs ever existed in our data set while making sure that we know still about all the other classes. And that we can perform as well on all the other classes. Okay, so for those of you who are more formal and more into research, this is a like very specific formula. So if you're having trained model H on your data set S, now you have a request to delete some part of that data, E4, let's say. What actually machine learning goal is to produce new model HDEL that would be exactly the same as if you would you would start from 0 and train on everything except E4, okay? So that's your goal. But obviously, usually the resources are very low, and you cannot just go and retrain models. Like GPT models take billions of dollars or millions of dollars to retrain, right? So you cannot just do that. Okay, so what can you do? We will go into this. Okay, so I also want to say why the title is so mentioning fairness and mentioning robustness and mentioning privacy, because machine learning actually started as a topic within a responsible AI and the way for us to remove the data, and it is practically a consequence of GDPR, because in GDPR, like if anybody doesn't know, you are required to remove your to be able to remove anybody from your data set. Now, it's hard even if you have a bunch of tables and big distributed systems with lots of databases and copies of it and so on. I worked at Facebook in 2018, so they had gone through a huge struggle with that even. But then imagine that you trained models with those data, and so now you have to like remove one person among billions of samples. So that is a new challenge that is just emerging, and it's going to be more and more popular in production, and it is currently getting high popularity in research. So why do we need this? So I work in medical data, so I'm going to start with that example. Imagine you are a healthy individual now, you've done some tests, and you sign this waiver that you're okay for your data to be used for research. But then 10 years from now, you figure out that you have a very rare disease that only 15 other people have, or you have a set of comorbidities also that is very rare. So you don't feel any more so comfortable sharing your data because people can discover who you are easily. And so you would like to be able to remove your data, but many models that hospital runs on, or maybe their research partners is using your data. So the only way for them to erase you is to be able to unlearn you from their models. And then more general than that, this is true for any user requested data. I mentioned Facebook, but any social network that you are using and anywhere else where you have given your data, which is basically any app you have on your phone. And also ChatGPT nowadays and all of these LLMs, as soon as you chat with them, you're kind of giving some information about you, even if it's a general search. So you should be able to remove all of that, especially if you accidentally gave out some like personal information or information about your job, and that happens quite often, unfortunately. So what are the other use cases? So the whole machine learning field kind of started from this point that people would need to be able to remove data. But meanwhile, some more important, I would say, things arose. One of them is cross-border data control. So you are deploying your model in multiple countries. Nowadays, almost every country is starting to have data protection rights, and so GDPR is just one of them. There are many others, and most of them want to keep their data within their own country. So you need to be able to unlearn parts of the models that you are keeping here in US, let's say, or in Canada, and that are data from Europe or that are data from India, because they don't allow you to do this anymore. So you need to be able to remove that data without retraining your model fully. You also need to be able to remove data in case of copyright claims, and the most famous one nowadays would be where New York Times sued OpenAI because they say that a model is generating New York Times articles. And now, obviously, the most cost-effective thing for OpenAI to do is unlearn everything from the training data set that comes from New York Times. And then we also have recently, and a first significantly good paper I've seen at ACL in 2022 on this topic is poisoning and attacks on models. The bigger model gets, the easier it becomes to figure out a way to attack it. And we've all done a lot of that with ChatGPT opened up, so lots of nonsense came out. And we've done simple versions of that, but there is research and there are very good models that are able to attack your production system and produce something randomly just by injecting few samples. And so you want to remove these poison samples. You also want to remove inadequate data that you use for training if you later on discover that's actually reducing your performance. So I don't know if you're following enough, but like ChatGPT, newer versions actually have much more refined data because they realized that originally scraped data from the internet that they used, some of that was so low quality that it would reduce the quality of their model output. So you want to be able to remove those without fully retraining. Okay, so what can be unlearned? So you can remove just one item, which is if a person comes to you and says, I want to remove my data. You can remove a feature. So let's say I've noticed that ChatGPT would output for you that a person who is non-binary has mental health issues with much higher probability than the person who is a binary gender, so female or male. So that is some feature that you would like to remove. And there are many others, I'm just giving an example. So what you want to try to do is like remove that feature from your model, remove that so that you can keep model less biased and more fair. And the other issues are like misclassified samples where there is a leak that comes from specific features and so on. And it can also be due to poisoning or due to attacks coming out from your enemies. The other one is data set wise, and this example would be OpenAI's, New York Times is suing OpenAI for this. So that is where they would need to remove the whole data set that comes from New York Times, but it's a small part of their overall data set. And the other one would be class-wise. When you would like to remove the whole class, an example of that would be if you know that your model should work only for adults, but somehow you have in your data set also people that are under that age, and then you would want to just remove that whole class of people without changing the performance on actual classes that you should have used, so people that are actual adults. So how does this work? So machine learning, as I said, has many options. I'm going to go here through instance forgetting option. So you as a person, let's say, in mental health, for example, there are options for you to scan your face so they can understand if you are, what is your feeling, how you're feeling, how are you feeling over time, and so on. And so let's say you're having issues with mental health, you think that's going to help you, so you accept to be part of that research. And then 10 years later, you realize that that data is now used for other purposes that you didn't want being used for example, police, face recognition. So you send a request and you say, I don't want to use this data anymore. You send it to the company, and then company has to figure out a way to remove you. And this is where machine learning is actually coming into play. So again, I just want to say that this is a very fake example. Usually nowadays, especially in like US, UK, Europe, Canada, this would never happen because the research is done with significant protocols, and the data can be only used for that research in most of the cases. So if you read it well, your contract, you should be okay. You will probably never need to request this particular thing, but there are other cases, right, of similar kind. Okay, so why not retrain? We already addressed this. I just want to show you the numbers, right? And this is not even the highest ChatGPT. Right now, so it takes $10 million to retrain. So it's not really something you want to do. Okay, I see some people taking pictures, so I'm going to go back. Okay, so I don't want to go through history, I don't have time, but for those of you who are interested in more research, these are the significant papers. So this field actually started 2015. Some work on decremental learning started in early 2000s already, but most of the work comes in the last 3-4 years. And I'm going to actually give you much more references later and places where you can go and read more. And also there will be a QR code at the end so you can actually download slides, so you don't have to take pictures, really. Okay, so what are the challenges? And again, I'm going to focus here on neural networks specifically. One challenge is stochasticity, right? So your neural network is actually like this thread ball. So single thread is simple, but then as you keep training it, you add so much randomness that on the end it becomes really hard to remove a single thread. Why is this? Because you randomly order your samples for training, you randomly split them in batches, you are using stochastic gradient descent, and also you probably randomly initialize your weights. Okay. So all of this randomness makes it hard then to figure out where exactly, and especially when you have huge models with lots of neurons and lots of connections, where exactly, which of those exactly come to represent your data that you want to remove. The other issue is incrementality. So the part or the batch one that you used influences your loss, influences how your loss changed or what you learned from it. So the next batch would only change, like the information that would be important in the next batch is only the information that was not already seen in the previous batch, right? And then the third one, the important part would be the ones that were not seen in the first two. So that incrementality means that if you like split your data in different way, if you have different batches, that means that you would learn differently and you would probably learn different outcome. So that incrementality is another issue why it's hard, another reason why it's hard to remove specific data. And the other one is catastrophic unlearning, and that means that once you try to unlearn that data, you still need to make sure that other information are still in your network and that you can perform as well on other data that you are not unlearning. That's called catastrophic unlearning. Okay. So these are the basic challenges. Then there are more significant challenges. One is balancing between what you're trying to forget and what you're trying to still remember, meaning the rest of the data. But you also need to do it as fast as possible, meaning that if your unlearning process takes you half of the time and money than full training, that's still a lot. Imagine like this $10 million, and even if it's $5 million, it's still too much. You want to do it in $10. You want to do it as fast as possible because your model needs to be online as much as possible. So there is a good balance that you need to strike between what you need to forget and how well you can forget it, what you need to keep remembering and how well you can still do this, and how fast you can do this. Another thing is transparency and explainability. So this is already very hard with big networks because your feature goes through so many layers and so on. But then once you try to unlearn some data, how does that now change the explainability of the other data that you're still representing? It's really hard, and it's really important, especially for medical use cases where you need to be able to understand what actually is happening here. The third thing, so efficiency, I already spoke about that, like you need to be able to do it as fast as possible. The most important issue here is actually security and privacy. So let's say that you have, somebody was able to record your model before you removed the data, and now after you remove the data. That means they are actually having the difference between your two models. There is a high chance that they might be able to figure out which data you removed. So instead of making that person that requests the data deletion more safe, you're making them less safe, and you're actually reducing their, you're kind of giving up their data to hacker that is having your before and after models. So there are also algorithms to make sure that this doesn't happen either. Okay. So to be able to deal with all these challenges, there are actually a lot of metrics. Verification metrics are there You can think of that like loss kind of in normal training. So these are the metrics that ensure that you optimize your model well against all of these challenges. And the evaluation metrics are then there to evaluate that performance. So there are many of these techniques, and I'm going to try to explain them. And there are more in the resources that I'm going to share with you. So you can go and read about all of them. So feature injection test is actually an attack that somebody can do on you if they know that you're using machine learning. So they can request for you to delete certain data, and they can inject specific features in that data. So that through unlearning process, you would actually scrap your model, and your model would start behaving badly because they injected some additional features into that data. So let's say I request for you to delete my data, but before that I add some additional information there. And while trying to delete my data, you actually inject some poison into your model. Another one is measurement. So you have to obviously be able to make sure that you're not doing that through unlearning. The other issue is how much you actually are able to forget and how much of the data is still in your model. So that's called forgetting measurements. Or information leakage is similar metric. So how much of that data is still leaked into your model? Membership inference attack is what I just described in the previous slide. So given your previous model and given your after unlearning model, can the person infer from the outside what actually was deleted? A backdoor attack is very similar to feature injection, except here, so people would try to inject something into your model in order to change its behavior and to make sure that predictions are different. So you need to make sure that through unlearning, you would close existing backdoor attacks. So that is one of the application of machine learning. So if you have poisoned model, you will try to remove that poison, right, and remove that backdoor. But also you need to make sure that you do not introduce new backdoor attack through this unlearning process. Slowdown attack is when somebody would try to reduce the speed of your unlearning for some reason. And interclass confusion test would measure your performance on the sets, on the data that should be staying in the model. So you had to predict 11 classes, you're removing the class number 11. How well do you now perform on the other 10 classes? How much do you confuse other 10 classes? What happened with your predictions to the class 11? Do you have issues there now? Okay. Federated verification is very similar to Friday's talk. So I don't know how many of you have been there. So on Friday, we learned about federated learning. And so what they do, they silo, they basically train models on edge devices. So they would, instead of sending your data from your phone to some server to train it, they would train the model on your device, and they would just send the predictions or some embeddings, but high-level ones. So if you have a federated learning model and you need to do unlearning, did you really unlearn well from each of these devices? That's a big issue, and this is what federated verification is for. And then cryptographic protocol is there to basically kind of use cryptography as one of the ways to ensure privacy and make sure that changes that happen between pre-unlearning and after unlearning are not discoverable by the attacker. Okay, and then evaluation metrics are very similar to, some of the metrics are very similar to what we would have for normal learning, but also some of them are really trivial and some of them are similar to verification metrics. So accuracy, completeness would measure like how well you still do on the other data. Unlearning time is how much you take to unlearn. As I said, if you're taking 50% of training time to unlearn, then it's still very expensive. So real learning time is kind of similar. So in some cases, you would need to do some relearning still, despite you trying to remove. So once you remove the data, you need to be able to also relearn. And then we have a layer-wise distance, which would measure the distance between how your layers looked before and after. You can also measure the activation distance. You can measure Jason's Shannon's distance, and so on. It is important to say here that two different models can perform in a similar way. So layer-wise distance doesn't really matter that much very often, because you can actually train a model with the same performance, and we've seen that a lot now with LLMs, that would have very different neurons and activations information in them. So that is not always a good metric. Okay, so I'm going to skip this because I see people starting to leave, and it's soon lunchtime. So what can we do? We can try to retrain from scratch, which only works with very small models. We can do early termination, though that means that we will try to, in advance, figure out which data set might be asked for future removal. So let's say if you know that you've trained with New York Times and that New York Times might decide to sue you, you can put that as a separate data set, and you can split your data, your overall data, into parts like that. And then you can actually train smaller models together and then fuse them. So what are the issues here? First, you need to know in advance, like 10 years maybe before or whatever, at least a year before, how to split the data. Second issue is, once you split it, you will be training smaller models. So can you really achieve the same accuracy? And the third issue is you are also training and you're saving checkpoints from all of these models at the time, so that you can roll back to points where you did not use this data. So you need to save a lot of checkpoints, especially for models like LLMs. This is impossible. This is very hard. So these techniques probably would work well if you have some medium problem, like BERT maybe is the maximum size that I would say this would work on. So most recently, most of the techniques are actually related to post-training unlearning techniques. So that is once you have full model trained, and then requests comes in to remove some data. And there are lots of techniques. These are just some of the basic ones. Target gradient ascent, where you would actually do gradient ascent for samples that you want to unlearn. Then you do some retraining, trying to, before that you can just remove some information from your model and then do some retraining, or you can try to think, okay, model is going to forget things that it didn't see recently, so I'm just going to keep retraining until it forgets the old stuff, which is questionable. Okay, the next one is pruning, where you would prune the edges between the neurons on the paths which would predict your data. So this would be the paths that are highly activated when the data you need to remove needs to be predicted. And the same is with weight reset, except instead of removing edges, you would remove the weights, or you would actually replace them with a random value. This will be the information in the nodes which are high when your data that you want to remove needs to be predicted. And then you can also create a custom loss that would penalize model for remembering unwanted data. Okay, so this is how your whole framework should look like for you if you would like to build in unlearning algorithm within your model development. And then there are advanced post-training techniques, and because I only have very little time left, I'm going to skip that. And you can learn about all those at the page that is Awesome Machine Unlearning page, and this is just, you can see code, you can see where it was published, what is the type of learning, and types of unlearning can be like model agnostics that work for many models, so model intrinsic that work for specific models, data-driven approaches, or general framework for machine learning. And then they also have some data sets, evaluation metrics that are more than what I mentioned. And I also listed here some additional papers that I didn't find there, but that are also very cited. And on the end, I just want to briefly discuss that security of machine learning. And I want to introduce you to two possible attacks there. One is the deletion inference, where the model, where the person can infer if you deleted some data, if you have performed machine learning. The other one is a reconstruction of the data that was deleted. If the person on outside of your organization can look into your model before and after, compare them, and reconstruct the data that was deleted. So both of them are bad, but the second one is significantly a big issue because you obviously are trying to remove that data so that it cannot be discovered. Okay, so how do you deal with this? So we can borrow some ideas from federated machine unlearning. One of them is just introducing noise, random noise, while you are unlearning, so that it will be really hard to understand, to figure out like what was actually removed. And the other one is using some kind of cryptography to protect your weights in some way, or your learning algorithm. So that's all. As I promised, presentation QR code. And if you want to contact me or look into my website, you can do it on the left QR code. Yes. Is there a microphone?
So with a lot of the unlearning stuff, it looks like it always, and the one that I know about is like the one where you try to increase the loss of the correctly predicted next token. I think you mentioned it in there, but is a lot of the unlearning techniques has to do with like trying to see the activations that did activate and trying to unlearn those specific neurons and everything. But because of the sort of probabilistic nature of language models and everything, there's no guarantee that there aren't other pathways within the model that aren't getting visited during your testing set. Yes. And so those pathways would never be unlearned, and so maybe sometimes in the future somebody might prompt it just correctly to get to data that it has learned that you weren't able to unlearn. Yeah, so you're talking about pruning or weight reset, right? Techniques here, and as I said, these are simple techniques, and these used to work, or these used to be proposed at the beginning, but obviously as we are going towards bigger models, that doesn't work very well. And as I already also said, looking into two different models, they can look very differently and still be able to predict the same data, right? So even if you train a totally different model, it can still somehow leak your data, right? So so there are, as I said, advanced techniques that are now trying to do something else, like masking your data, multiple pathways, and then you can do that iteratively then, right? If you mask a pathway that is the best predictor, and then you try to predict again, and then you try to mask again, and so on, right? But then the issue is how much masking you have to do, and how do you make sure that you still have good performance on the data that you're keeping, right? Okay. So there are many things, you can read more. I just didn't have time to mention. Are there ways of quantifying like the amounts in the masking model? Like, you've unlearned by increasing the loss in this particular pathway. Are there ways to quantify how much it's unlearned from that data set if you do the masking or something? How much is unlearned? Yeah, because so this is a metric. So you can do forgetting measuring, right, or information leakage to see how much is unlearned, and then you can also try to do accuracy or completeness metrics to see how much was kept. So it will be the balance between those two. Okay, thank you. Yes.
Thank you, Marija. Wonderful, really great presentations. I enjoyed it. Quick question regarding the privacy and security of the data. So I understand the propositions, but at the same time, like let's say a closed model and open source model, and the model which was internally developed by an organizations, because like masking those data and republishing the model, which is more protected, like it's not available, the weights are not available, even though and initially, like when some customer files a complaint, they will remove it, and it's related to that customer only, right? How this thing's gonna play out in the closed source model? Because like, in closed source model, they're not gonna remove one data points, but they're gonna batch all the things that they're gonna remove, and then they're gonna execute the whole retraining or the whole process they're gonna do, the unlearning process, right? So batching would help right away, especially if you're removing different type of users or different type of data.
but it would still not guarantee. And the fact that model is closed, it just depends on how good your hackers are, you know. We had, I think, Mistral or something, which somehow somebody leaked their model. And also your employees can leak your model, right? So the fact that something is closed is not perfect solution. So you should always try to build the model with security in mind. And as I said, some of the ways is like what you said. The other ways is just introducing noise when you are unlearning. And the third ways is using some kind of cryptography when you are both learning and unlearning, or even at least when you're publishing the model, or you know, where you're putting it into production or somewhere where it's accessible by the internet. Did I answer your question? Because I might not have.
No, you did. Thank you.
Okay, yeah. Do we have time? Okay, it's lunchtime, so whoever wants to leave, you're free to leave. Who wants to stay with questions, please do.
I invite you to continue conversation
Yeah.
after the fact. So thank you very much, Marija, for the
Yeah,
presentation
thank you.
today.